Following the release of my video on the Z80 architecture, I decided that it might be an idea to dust off my oldest computer, which is a Nascom 1, and do a review of it. The Nascom 1 was originally produced as a kit in 1978, and was originally only expected to sell no more than 500 units. It went on, combined with its successor, the Nascom 2, to sell over 35,000 units. As you can quickly tell from the computer you see before you, it has had, over its lifetime, a few modifications. The basic computer came with 2K of memory, 1K of which was for the video display, and a 1K ROM. By the time you powered it up, you had around 800 bytes in which to create your programs. However, you had to assemble the board first, and solder all of the 203 components into place, in total around 1,300 solder joints. It did, however, ship with a fully built, and for the time, excellent keyboard. Unfortunately, I no longer have the keyboard, and the computer itself no longer functions. It's on my to-do list to renovate it, but it's likely to be a major project. The original Nascom 1 board is 12 by 8 inches in size, and as well as having a Z80 processor, it has the PIO chip as well, which I've put to good use. Here we can see the cassette interface, to allow saving and loading data to tape, and the connector for the video monitor. The ribbon cable is for the keyboard. Here we can see the output from the two PIO ports, and you'll see what these connect to when I turn the rack around. In order to expand the computer, there was an edge connector, which originally needed to be connected to the Nascom buffer board, one of these. This allowed other 8-inch cards to be added to the system. This original design was a bit awkward at times, and I later replaced it with the combined PSU and backplane that you will see in a moment. But these support chips did make it possible to add a vital memory card to the system, and much larger programs could then be run. Here we can see the original ROM chip occupying one of the two ROM sockets. This ROM held the monitor application that was your very minimal interface with the computer. There were, of course, lots of little add-ons you could purchase for the computer, like this one to allow easy switching between ROM chips. If we turn the computer round to see the front, we will get a good look at what has been added to this Nascom 1. Prominent on the left are the two digital tape drives. These are controlled by the Nascom's two parallel input-output sockets. Contained within the drive is a small digital cassette tape. These drives allowed loading at much faster speeds than the normal cassette interface. And in addition, each tape had the equivalent of a file allocation table on tape, an index to the files stored upon it. You could query the file stored and load or save any file by name. Combined with the Crystal Basic, it made the writing of applications much easier. With two tape drives, you could read data in from one drive, process it, and output to the other drive. On the right, we can see the power transformer and elements of the power supply built into the backplane. It has a fairly chunky 5-volt regulator and some large capacitors. If we angle the rack slightly, you will be able to see another add-on board. This was to expand on the character set by adding a second ROM. This made designing forms much easier, as this ROM had many special characters that could be used for horizontal and vertical lines and corners. If we pull out the 64KB memory expansion board, you can see a full 64KB of RAM and 4 slots for ROMs. In these, I have 2 ROMs for NASPen, which is a 2K text processor application, and 2 further ROMs to control the Philips digital tape drives. Obviously, adding 4K of ROMs to the board does reduce the RAM available for programs, but the software on the ROMs was essential. Modern computers do of course have vastly more memory, but with 64 kilobytes on this computer combined with the tape drives, you could do a lot. Everything in your Z80 coding was about efficiency. Next, we can have a look at the second board. This is a colour graphics board. Of course, the resolution and number of colours it could display were vastly inferior to today's computers. But this was cutting edge in its era. So this Nascom 1 could support two monitors, one black and white for programming and one colour for display output from your applications. Again, fairly groundbreaking in its time. For printing, I had a teletype printer connected. Reports of the room shaking when I printed something are exaggerated. Connecting early modems to the Nascom 1 was also possible via the serial port. In that time period, bulletin boards were what you connected to, as the internet as we know it now was some years off. I added a second Nascom 1 later, which at that point you could buy fully assembled. Even after I started using other computers, notably the New Brain, I still kept the Nascoms running. But what was the Nascom like to program in machine code? The basic machine had so little memory you couldn't use an assembler, as there just wasn't room for it. You had to use the hex codes. And here we are running the Nascom 1 NASBug 4 monitor. This is via an emulator of course, but it does give a true representation of just how minimalistic an interface it is. You can get help with the question mark. And yes, that's all the help it gives, listing just the command letters it supports. So let's list out the current values sitting in memory from 1000 hex. In machine code, it's all hexadecimal, so you stop thinking in base 10 decimal quite quickly. So let's try that again and list out, or tabulate, the values held at 2000 hex for 20 bytes. Now that we can see the data at both locations, we're going to write a short program to copy data from 1000 hex to 2000 hex. We'll use the M command to modify memory locations, and start by loading 1000 into the HL register pair. Next, we will load our destination into the DE register pair. And finally, we will load the number of bytes into the BC register pair. Note that all these values are loaded in with the low byte first. Next, we're going to load a command to copy data from the memory location pointed to by the HL register pair to the location pointed to by the DE register pair, and then increment both sets of pointers and repeat, decrementing the BC register, and loop until the value in BC is 0. Finally, we will use a return command to return to the calling process, which in this case is the monitor. So let's just check the data held at 2000 hex once more. Now we will execute our program sitting at 1000 hex. And here we are, back in the monitor. So has our program worked? Let's list the data again at 2000 hex. And there we can see the short program copied from 1000 to 2000 hex. Coding in assembly, rather than machine code, does have advantages, especially with labels. However, when you only have 800 bytes to play with, you learned the Z80's machine code operands. Hopefully you will have enjoyed this little trip to visit an early home computer. But that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.